Alright, we are going to start with addition. We're going to be covering the different operations you can do with polynomials. Addition, subtraction, multiplication, and division. So we're going to first start it off easy. We're going to be just focusing on one variable at a time. That way we can just focus on the operation. Let's get right into it. So let's say you have an example that says, oh no. Oh, okay, I'll be right back. I need to go get yet another marker. And we are back. I did find a better marker. So we are going to, let's see if I can get this closer. Alright. We are going to add (3x squared) plus x plus 4 2x squared, curly x's, plus 2x minus 16. Alright, so what do we do first? We're going to identify our variables. Here we see that our only variables are x. We also want to take into consideration the powers or the exponents on those variables. So we have x squared, we have x to the power 1, just x squared again, x by itself, and these two are constants. Great! I could really just bring these down here and just add them up like how we do in normal addition with normal constants. But I do want to point out, you do have to be careful if there is a minus sign. We're going to be getting into that more in the next section. But let's look here. What are our like terms? So we have 3x squared and 2x squared. We can combine those together. And we'll get 5x squared. When you're actually doing your addition, you don't necessarily have to draw arrows like I'm doing. You can go ahead and circle them as you go, circle, and then maybe for x you could do like a box or a triangle, whatever suits your fancy. Okay, so then we're going to do it with x just by x. So this is x and then plus 2x. That's going to be plus 3x. And then we have a minus 4 and, positive 4 and a minus 16. We combine that, we get minus 12. Woohoo! We have our answer. 5x squared plus 3x minus 12. That is our answer. At this point, we actually don't need to simplify. We did not need to simplify for this problem any further. Sometimes you might have to. So, ta-da! Polynomial, addition with polynomials, not too bad, pretty easy. You're just combining like with like, just like what you're organizing in your closet. You're going to organize your shoes together, you're going to organize your shirts together, and your hats together. Okay, so here we're going to need to simplify in yet another question we're going to do. Oops. So a question that asks or tells us add 5x squared plus 8x to yet another polynomial, which is going to be 2x squared minus 6x plus 14x. Yes, I do mean 14x, not 14. Plus 14x. Whenever you're adding two different polynomials, you actually might not get each degree or matching constant in both sides. So here we have x to the power 2, we have x, we have a constant. Here we have x squared, same thing, power of 2, x to the power 1, x. Over here, there's no constant. So this constant is not going to be matched up to anything. This is just going to be the loner, which is going to drop down into our addition. This 14x is actually going to be combining with in here, and it'll later combine with this. Or if you feel comfortable with it, you could just combine all three of them, 8x, negative 6x, and positive 14x together in one go, if that's what you're comfortable with. So just to make it simple, let's do this. Let's simplify within the parentheses, following Penn does. And let's not get ahead of ourselves. So we're just gonna drop down the first polynomial on its own. Now here's where we're gonna combine. We're gonna have negative 6 plus 14x. That will leave us with plus 8x. Yes. Alright. And that's just x to the power of 1. Great. So what matches here? X squared, x squared. So we add those up, we get 7x squared. And then we're going to add this 8x with this other 8x. We're going to get 16x. And well, the negative 4 doesn't match with anyone, so it's just going to be dropped down to minus 4. Ta-da! We have simplified this polynomial. We have simplified and added. Great job. Great job. Some of you might remember where there's more variables involved. The same thing applies. If there's like this is not the same as. The variable right here needs to match exactly. So for those of you who are like, let's say that you are doing a paint job on a car, and you're gonna you have to get like the hood replaced. You're gonna want it to match the same color of the rest of the car. If it might be let's say you have a red, a particular shade of red of a car. Let's say you have a maroon car, and the hood you just buy just a red hood, but it might be a scarlet, it might be a burgundy. You want it to match exactly, otherwise it's gonna look off, it's not gonna work out. Same thing with math. It wants to be a perfect match. Might look a little similar, and this is why people always recommend, if you have like poor vision, or if you need reading glasses for the exam, go ahead and bring them, even if it's not so much for seeing far away, because you are on a computer and you're gonna like be focusing like at a certain distance at the same amount of time, your eyes might get tired, which is another reason they also recommend that you get a good night's rest before the exam, because you don't want to be tired and like float over this power of 2 over here to B. So just be very mindful. It's got a perfect match. If it's a perfect match, it doesn't go. You're not going to add it in, you're just going to drop it down. Alright. Next problem. Great. Now we're going to go on to subtracting. I do want to mention all of this is a polynomial. This is another polynomial. So we added this polynomial with this polynomial. Okay. Oh goodness gracious. I had put that way you wouldn't have to hear the banging noise as much. Okay, so here we're just going to focus on one variable. So now it's going to ask or tell us to subtract 3x squared plus x plus 4, and we're going to subtract this other polynomial, 7x squared plus 2x x minus 16. Now, I do want to point out that when we're subtracting polynomials, something that's going to come into play is our distributive property. Let me explain. Remember whenever you have a negative sign or positive sign, there's actually an invisible one? Truly, this means -1 times so maybe you may be asking like, well miss, like we were doing subtraction, how did we get to multiplication? Yes, we are going to end up subtracting this polynomial from this one, yet in order to like turn the signs, because when we were adding, we were just combining the signs together, which is like bloop, bloop. Here, we're going to need to distribute that -1 in order to make the reverse of the signs inside the polynomial. So if I go ahead and multiply -1 times 7x squared, so I get -1 multiplied by 7x squared, and I'm drawing it out like for people to like see what I'm doing in this step. You might be able just to go from this step to like the next step I'm about to do. Don't worry, we're learning, we're understanding how this works. Great. So we distribute this -1 with this term. Great. Remember, we don't break apart things into terms, we keep them together. Next, we're going to multiply the -1 by the positive 2x. Now, it's going to be we're going to add it because there's already the negative over here. Multiply that by 2x. Great. And now we're going to add it by -1 multiplied by -16. Minus 16, same thing as -16. We're going to keep it as is. Once we now simplify here, we're going to get -7x squared, and then we have, so we're just going to put plus, and then right here we'll just put a negative. We don't want to get confused in our signs yet, or ever. So -1 times 2x is -2x, and then I have plus, so a negative times a negative is a positive. Great. So this is just going to be 16. Further simplify it by just getting rid of that negative sign and just put in a subtraction sign. It comes in handy to put subtraction as a negative, and other times it's just easier to put subtraction of a positive number. There are different times when it's just easier to keep track of things. It really comes down to your personal preference, and also what is the truest simplified version, because this is not truly simplified. This is simplified. So this is not my final answer. I'm not done yet. You might actually get an answer choice that has this as an answer. You're like, oh yeah, I solved it, great, move on. No, you did all of that hard work and you still haven't done what the problem asks. It wants you to have this, subtract it from that. Whoa. So let me just write it over here. At this point, it doesn't matter the order. Like if I subtract this one from that one, or if I like let's say whenever you add or subtract, order does matter. Like what you put the number minus the number. This is very important. Like which number goes on top. But since you now have done like your distributive property and you've inverted the signs of each term, you can just go ahead and treat it like addition. Woohoo! Much easier that way. So I'll just go ahead and just put them together. I have 3x. Whoop! I forgot to do the squared. Very important. This will ruin all of your good work if you forget to write like even just a negative symbol or an exponent. Squared x is 4. Great. So I lined them up. They all go together, and I'm pretty much just gonna add. So negative 7x squared plus 3x squared is the same thing as negative 4x squared. Negative 2x plus x is just negative x. Then I have positive 16, and I add it with 4. I get plus 20. Double check my notes. Yep. We have effectively subtracted 2 polynomials. Isn't this exciting? So we were able to turn subtraction, which was like a really scary thing. I remember when I was first learning to subtract in elementary school, it was a little scarier than addition. But here, we just inverted the signs and woohoo! We could just go ahead and treat it like addition afterwards. Great thing with terms. I love this. Let's do one more example when we're subtracting polynomials with one variable, being, in this case, x. Now, it might not always be x, it might be y, it might be some letter, or some other placeholder symbol. It doesn't matter. A variable is a variable. So we're going to subtract x squared 2x plus 13. We're going to subtract this polynomial, 4x squared minus x plus 6. Same thing, distributive property. Alright, let's make this easier. Let's kind of just take a shortcut. So we're just gonna change the signs of whatever's inside this polynomial because of this -1 that's being multiplied by each term. So we have -1 times 4x squared. We're just gonna put -4x squared. Oh, negative and a negative, we get a positive, so it's just gonna be plus x. Then we have negative and a positive. It's gonna be a negative. Ta-da! See? This is getting a lot easier. Great. And it seems that every single term in both polynomials has a pair. You have x squared, x, and a constant here. Wonderful, wonderful. Okay, so let's combine these. So we have x squared minus 4x squared. We're going to get negative 3x squared. And then we have 2x plus just x. That's 3x. Plus 3x. And then we have 3 minus 6, which is just going to be a minus 3. 3 plus. Okay, yes, we have properly subtracted these polynomials with one variable. Yay! See, algebra is not so intimidating. We are working our way through, we are taking it slowly, and we are seeing that it is not so scary. Great. Now, we're going to try this with more variables. And I hope I have enough room on this tiny little board. Okay. So here we're just going to deal with simplifying. Because we need to train our eyes that we're only going to be looking at combining like terms, and like terms are only terms that have the same variables and the same power, or same exponent, the little floating number at the top. So we're going to simplify 6x y to the power of 4 minus 20x squared minus 3 plus xy to the power of 4 plus 12x squared minus 30. Still checking that I copied everything correctly. Okay, so first things first, we're going to start grouping our like terms. I know that there's a whole lot more terms here. Start putting them together. Let's identify them. xy to the power 4, we have x squared, just a constant, xy to the power 4. Hey, we saw that just now. We also have 12x squared. Hey, x squared, x squared. Remember, when you're a like term does not need to have the same coefficient. These two, and let's use a different color, are like terms. This one has a coefficient of 1. They have different coefficients, but the fact that they have the same mix of variables, xy to the power 4, xy to the power 4, makes them like terms. Same thing here. We have negative 20x squared and positive 12x squared. I don't care that there's a negative 20 and a negative 12 at this point. They both have x squared, and x squared goes with it. Just like when you're putting things in your closet, you're going to be putting your boots with your boots, you're going to be putting your sneakers with your sneakers, you're going to be putting on your beanies and with your beanies, and your baseball caps with your baseball caps. They may be different colors from each other, or they may be different styles, but they'll still be put together. Okay. So let's start just doing a grouping. So we have 6x to the power 4. The simplifying really means add. So let's put these together. We get 7xy to the power of 4. Okay. Now we're going to deal with this term. Negative 20, positive 12. When you're adding and subtracting exponents, variables, you don't really deal with the variable itself or the exponent. You're just going to be dealing with the coefficient. This is where the coefficient now becomes important, when you're actually getting to the simplification part. But when you're identifying like terms, not yet. Negative 20 plus 12, what do we get? We get negative 8 as a coefficient. And then we're just going to drop our variable with the appropriate exponent. And then we have negative 3 and negative 30. That becomes negative 33. Yay! We have simplified a polynomials with more than one variable. Yay! We would actually call this two different variables. This variable and this variable. The 33 is not considered a variable because 33 is a constant. How can you vary if you're constant? Okay, let's add a polynomial with just one variable. Now we have add this polynomial Okay, remember how I said simplify and add are pretty much the same thing? If I swapped out the word add for simplify and I just like dropped the brackets, it's the same thing as simplifying. Woohoo, we love adding. So let's just look at our like terms. We're adding, there's no negative, we don't gotta distribute anything. We just start immediately combining. And look, we have x squared as variable. We also have xy as a variable. And I'm just using like arbitrary things to match. And those are the only variables that match from both polynomials. X to the power of 1 is a linear, doesn't have anything else that matches in that variable. And then y to the power of 1 doesn't have anything that matches from this polynomial. So those two terms are just going to be dropped down. So the only things that can be combined truly are these terms and these terms. Okay. And keeping track by like manually labeling them really helps out a lot. But I know if you're taking a digital exam, how can you really draw like this? If you're rewriting the problem, go ahead and just rewrite it as it is and then try to label. You don't want to get caught up trying to like order this xy and this xy to be like the same numbered value in the sequence of the polynomial, because you might have things that don't match, don't throw everything off. Been there, done that. So let's combine 3x squared and 5x squared. We get 8 by adding the coefficients, and then we just bring down the variable and the appropriate exponent. Next, you know what? Let's deal with, let's just drop this guy down. Because we read from left to right, and let's just attack this, attack it from left to right just so we don't miss anything. I might already want to like combine these two like terms, but I might forget to deal with this. So just to be very methodical, let's just drop this down. Okay. Did that. Now I need to combine these two. 3 minus 6. I will get -3. And I'll drop down the variable. Wonderful. Over here, there's nothing to match. I just drop down the entire entire term. And this is my answer. Now, if you recall, when we were dealing with polynomials that only had one variable, such as x, we did order it from greatest to least and the value it had for the exponent. But here, when we're dealing with two variables, that does not become as important, and I am actually going to warn you because it is less important. Your answer choices might have the term scrambled. So just because your answer does not match the sequence of the answer choices does not mean it's wrong. If you just move around the terms, it's really just the same polynomial. Be on the lookout for that. That's why they say sleep 4. Alright, so we did simplification, addition, and subtraction with one variable. We also did simplifying and addition with more than one variable. So the only thing we have left to do is subtraction with more than one variable. So let's write subtract. xy squared plus x plus 2x y plus 4. Ooh, okay, let me redraw that 4. It might look like a 9 to some of our viewers. Also, if you are watching this on YouTube, the little gear icon, you can click on it, and you can, if you have like 144p, the image is going to be really blurry. I recommend to watch the video at least in 480p, that we can see the image clearly, and if you have the bandwidth, you can try 1080p or even 720p, and that's just like the quality. The bigger the number, the higher the quality. I also wanted to mention that the City of McAllen is allowing card users, like people who have a library card from the City of McAllen. You actually don't have to be a resident of the City of McAllen to have a library card to the City of McAllen, and they're letting you rent out little hotspot devices. I know a lot of you are using a hotspot from your cell phone data plan, and I know that's usually might be inconvenient. So if you rent the little hotspot, it's able to like handle more devices, and it's a device made just for that versus a cell phone, which is made for many different functions. So I'll go ahead and email that. I'll actually put up that information, even put their link down in the comment and the description below this video, especially when we're working virtually. I'd hate for anyone to get behind because of lack of access. Right. Back onto subtracting polynomials with different variables. Okay, minus. Ooh, I hope I have enough room. 7x squared plus 2x y minus 16. That is a 7. Let me just double check. Yes. Okay. So what do we do here? We do the distributive property. Remember, it's an invisible invisible 1 right there. We're going to distribute this -1 to every single term. So really, this is -7 xy squared. Honestly, I'm just changing the sign. If it was positive before, I'm changing it to a negative sign. If it was negative, I'm turning it into a positive sign. Here it's positive, so I'm going to turn it to negative 2xy, and this is negative, negative. Negative and a negative make a positive. Boom. From here on out, I can just start matching up and simplify. Okay. Now I have to make sure I am combining the like terms with each other. So I know these two match xy squared. We have xy here and xy over here. We also happen to have two constants in each polynomial. Great. And x, well, there's no matching x term over here. So that one's just going to be dropped down. Wonderful. Put these together. I'm going to combine the coefficients. 3 and -7 essentially is 3 minus 7, so it's going to be -4. And then I have, this is a variable. And I have plus x. Okay. And then we have a +2 and a -2. Okay, so that's 0. So everything goes away because if you multiply a coefficient, so the coefficient is multiplying a number to the variable, but if you multiply anything by 0, anything, you get 0. So bye. Really, it's gonna be, which is really just 0, just bye, it goes away. And then we just deal with our constant. For those of you who are like screaming behind the screen saying, but miss, I thought you said 0 was neither positive or negative. That is correct. But since whenever we are simplifying, it's really just another way of doing addition, and another way just to carry this out was to put a plus. So we have a 4 and a 16. We get a +20. So let's go ahead and rewrite this. X. I mean, that's 0, so we don't deal with that. Or just forget about it. And this is our resulting polynomial. There we go. Okay, so now we're going to be getting into multiplying polynomials. And then after that, we'll be talking about dividing polynomials. However, this is a great time just to take a break. And I'll actually even think I'll divide the video into 2 parts. So I'll go ahead and do